Welcome to my math class. I am Mohammed Ali, online maths teacher. Today, from Mathematics D, graph chapter, we will try to solve some question related to turning points. A turning point or stationary point is a point on a graph where the gradient is zero. On the cubic graph, on the right, there are two turning points. This is one turning point, that one is another turning point. Above, completing the square was used to find the turning point on a quadratic curve, but for other graphs, this does not work. Previously, we learned about completing square. Completing square only used for quadratic function or quadratic graph to find out the turning points. But for other graphs, cubic or quadratic, so we have to use the turning points or stationary point by another method. So turning points for the other graphs and the quadratic graphs can be found by setting the derivative function equal to 0 and solve the resulting equation. Turning points are often referred to as a local maximas or local minimas. Now we try to find out the turning points in another method, derivative by using the derivative function equals to 0. Here one example given, like fx equals to 3x cubed minus 2x squared. If you want to find out the turning points, at first we have to do the differentiation over there. So for turning points, where the differentiation we get, the differentiation is always equals to 0 because this peak position or this position, here the turning points, so differentiation equals to 0. So from this differentiation we get the two values of x, and for these two values of this x we will get the corresponding y value. So these are the turning points, and after that we will learn how what will be their turning point. Is it maxima or minimum? Now see, from exercise 19, question number 4, we try to find out fx equals to 2x cubed minus 2x squared minus 3. A. Find the exact coordinates of the turning points on the graph of y equals to fx. This is the first one. Number B. Determine the nature of the turning points. Okay. Question number 4. Fx equals to 2x cubed minus 2x squared minus 3. At first, we will find out the turning points. So we have to do the differentiation at first. F prime x equals to 2 into 3x squared minus 4x. When differentiation the constant, it is 0. Here I have shown you the differential formula, like y equals to x to the power n. If you want to differentiate this, dy by dx equals to n x to the power n minus 1. Now it is 6x squared minus 4x. For turning points, the first derivative f prime x equals to 0. Now 6x squared minus 4x equals to 0. So we have to take common 2x. So we'll get here 3x minus 2 equals to 0. After that, 2x equals to 0 or 3x minus 2 equals to 0. So x equals to 0 and here x equals to 2 by 3. So these are the two coordinates of x coordinate. Now we have to find out the y value. When x equals to 0, we have to put this in this function. So y equals to f0 equals to 2 into 0 cube minus 2 into 0 square minus 3. So y value equals to minus 3. So 0 minus 3 is one stationary point. Another one, when x equals to 2 by 3, we have to put it in this function. So y equals to f 2 by 3 equals to 2 by 3 cube minus 2 into 2 by 3 square minus 3. So y value we get here minus 89 by 27 minus 89 by 27. So another stationary point is 2 by 3 comma minus 89 by 27. So the turning points are uh, 2 by 3 minus 89 by 27. This is one turning point. And another one is 0 minus 4. Now, P number, we want to find out the nature of the roots. If we want to find out the nature of the roots, we have to do the double differentiation. That means f prime x, if we again differentiate this, it will be f double prime x equals to 12x minus 4. Now, when x equals to 0, f double prime 0 equals to minus 4, that means negative. When it is negative, so the turning point 0 minus 3 is maximum. When double differentiation equals to 0, after putting the value of x, if it's negative, that means the turning point 0 minus 3 is maximum. So another part, when x equals to 2 by 3, we have to put this in double differentiation. That means f double prime 2 by 3. So we'll get here 12 into 2 by 3 minus 4. So it will be 8 minus 4 equals to 4. That is positive. That means when put x equals to 2 by 3, it's positive. So the turning point, 2 by 3 comma minus 89 by 27 is, when it is positive, then minimum. I think everybody understands this maths. At first, we have to find out the turning points. Then we do the first differentiation, and first differentiation goes to 0. From here, we get the value of x. And the question number B, when we want to find out the nature of turning points, is it the stationary point is maximum or minimum? Then we will have to do that double differentiation. Here we put the x value. If we put the x value, if we get double differentiation result negative, then the turning point or the stationary point is maximum. When double differentiation result is positive, then the turning point is minimum. So I think everybody understands these things. So that's it today. Now one request for everybody, please plant more trees. To protect the global warming of the earth, please plant more trees. Thank you everybody for watching. Thank you all.